Joe, we're at episode 31. Can you believe it?
It's quite a few episodes.
Quite a few episodes. Getting up there.
I know. You've been on quite a few of them. Jared's, he's just playing hard to get at this point. He's my normal guest, but honestly, you're a great guest, especially for this, because this is, and I don't say this lightly, probably the most advanced chemistry topic that I've learned. And of course, it's all been crammed in the last few days because of this acid shortage. But that's what we're going to be talking about today. And I have done so much research, and thank God for you, because you are a guy with a chemistry degree. So I'm going to be leaning on you on this episode, even though you didn't do any of the research I just did. So I'm going to put you on your toes, Joe. We're here to talk about the acid shortage and acid alternatives today. Are you ready to get into it?
Ready to get into it.
For those listening at home, we're going to see how Joe does. We're going to really test his mettle today. But I've got this whole list of facts and figures, and I've got 26 tabs open on my Chrome browser for all this research on acid alternatives. And yeah, we're going to see how it goes. So without further ado, this is episode 31 of the Rule Your Pool podcast.
Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go.
Joe, muriatic acid is running short nowadays. We've been hearing it certainly on the West Coast and in Arizona and in Dallas. When acid comes in, it's sold within a day or within a few hours. Everybody's looking for acid. And we just recently did an episode on how to reduce your acid consumption. In fact, I think that was episode 29 on how to contain pH instead of chasing it. But at the end of the day, if you can't get any acid, what are our options?
I mean, it's what people are used to too. I mean, even though there are alternatives out there, it's, people want muriatic acid because that's what they're used to. Mm-hmm. But we're fortunate, there are a couple of alternatives. There are the sulfuric acids, there's sodium bisulfate, and these things can work. You just have to know and understand what you're using.
Mm-hmm. And today we're going to talk about 3 alternatives. And actually, there's technically 5. 2 of them are specialty. In fact, let's knock those specialty ones right out because they are a form of hydrochloric acid. They are a type of muriatic acid. I don't know their supply chain situation. Maybe they are still available, but they are specialty products. 2 brands in particular are Acid Blue and Acid Magic. That is just a different form of hydrochloric or muriatic acid with some stabilizing agents unknown. They're proprietary, but they fume less. It's a lot safer to handle. Good products, by the way, really good products. But we're not really going to dwell on those. If you can get them, great. That's going to be, I believe, the same dosing as muriatic acid. But we're going to talk about alternatives to muriatic acid.
Yeah, and we should
say probably in that, Eric, that muriatic acid is hydrochloric acid. It's just a diluted version of it.
So. That's correct. Muriatic acid is 31.45% hydrochloric acid or less. So you could have 15% or whatever, but commercially available, almost everything you're going to see in a pool store or in distribution or anything in the pool business is going to be 31.45%. That dominates the market. And that way the dosing, like the dosing on our app, on our Orenda app, Joe, that's for 31.45% muriatic acid.
Yeah. Right. Good thing it's not 31.35. We'd be so far off.
Oh my gosh. Yeah. Oh, you had to go there. Okay. Well, we're going to get into some... Dang, Joe, we're going to get into some specific numbers here. And, it's not like I don't have this giant sheet of all these facts and figures. Now you got to confuse me even more. This is great. All right, we're going to talk about 3 alternatives here. Sulfuric acid, sodium bisulfate, and injecting carbon dioxide. What do you want to start with, Joe?
Oh, man, tough one. You want to start with sulfuric acid?
Sure. Sulfuric acid is H2SO4. All right, it's a very strong acid, and it is sold at a 38.5% concentration. All right, unlike 31.45 for muriatic, it is 38.5. Now, this concentration is sold this way because it's very comparable with standard muriatic acid. It takes about 2% more sulfuric acid by volume to have the equal pH and alkalinity impact. In other words, take your muriatic acid dose times 1.02, and that's how much sulfuric acid you need. Okay, so it's very, very close. One example of this, I believe I have right here. I got to pull this up, so bear with me, folks. Okay, So if I'm going to do 1 quart, 32 fluid ounces of standard muriatic acid, it's going to take 32.64 fluid ounces of sulfuric. So it's almost identical. I mean, we're talking 0.64 of an ounce. How much of a difference is that really in a typical dose? So most people just dose it the same. You technically need a little bit more, but Joe, as we say, we always vote to err light on acid. So if you do the exact same dose for sulfuric, you're not really hurting yourself. It may not make all of the same correction, but if you're going to err light on acid, so you could do the same dose for sulfuric for sure, because it's 2% lighter.
Yeah.
Okay. Now, don't get confused on the concentration because it's 38.5% versus 31. That's irrelevant to this conversation. That percentage is all based on what it can actually do in the water. Okay. This is a different acid. In particular, we're going to talk about a byproduct, which we're going to probably have to focus on in this episode, of both this and the next type of acid, sodium bisulfate, called sulfates. And we're going to get to that soon. The biggest difference between these acids is basically what is left behind. Okay, so we're going to talk about sulfates soon, but hydrochloric acid only leaves behind chlorides. And every type of chlorine in your water already leaves behind chlorides. They're pretty innocuous. You already have them in your water, you're guaranteed. But when sulfates and chlorides are in the water together and you have enough of them, corrosion runs rampant. Okay, and we're going to get to that soon. But that's the basic difference between sulfuric acid and muriatic. The other thing is sulfuric acid fumes a little bit less. It's a little safer to handle in this concentration, but it'll still burn your skin. It's still very hazardous. It's very corrosive. It'll absolutely etch concrete the same way. You have to treat it just as safely as you have to treat muriatic acid. There's no exceptions to this. Proper safety gear is absolutely recommended. Anything you want to add to that before moving on, Joe?
Always add acid to water, never water to acid. You can have a pretty volatile reaction with the acid and water, even when you're doing it the right way. Mm-hmm. So eye protection, as Eric said, but being cautious with it, little at a time. Again, err on the light side if you have to err on one side or the other. Mm-hmm. And as with any chemicals, storage and handling are critical. Make sure that you understand where to keep, what, and look at the chemicals for their storage instructions, because you definitely want to keep your pool chemicals separate. In some cases, they can be hazardous, even toxic. They can cause fires. So these are things, the acids that can do that. All of them we're talking about today.
Yeah, absolutely. Do not mix them directly with chlorine or even in high concentration in a bucket with chlorine. We just saw this really scary water park incident in Houston this past week where, according to reports, again, we don't know all the facts at this point, so we're not going to give our opinion on that. But according to reports, it was a leak of some sort involving chlorine and or sulfuric acid. Either they got together or they leaked out in too high concentrations. Whatever it was, when those two mix, it is very, very toxic, and it put a lot of people in the hospital. And so our prayers are with all of those people, and we hope that gets resolved. But these things can happen. This is a very volatile chemical. All right. Now, I saw a video on YouTube in my extensive research, Joe. Of course, I was on the YouTube rabbit trail because that's what happens. They put a drop of sulfuric acid on a pile of sugar and it exploded. I mean, just red flames, whoosh. Just one drop of acid did that.
Disclaimer, we do not recommend doing this at home.
What are you talking about? You got to do this stuff at home, people. No, of course not. I mean, it's crazy, but you can find it on YouTube yourself. This is not a chemical to play around with. Of course, muriatic isn't either, but it reacts differently with different things. So just assume you have to dilute it. Well, don't assume. We're telling you. You have to dilute it. It is heavier than water. It'll do the same thing that muriatic will. It will go to the bottom of the pool. It will etch the concrete. It will pull out calcium hydroxide if you have a plaster-type pool, or it will fade your liner over time, or etch away at the gel coat in your fiberglass pool. Whatever surface is irrelevant. You need to dilute your acid, and it will correct I shouldn't say correct. It will reduce your pH and alkalinity almost identically to muriatic. Now let's move on. I went down the rabbit hole too far. The next one is sodium bisulfate. Now, if you're thinking sulfate, sulfur, yeah, it's the same element, sulfur. Sulfuric acid and sulfate, sodium bisulfate, also leave behind sulfates. This is the byproduct, okay? Now, of course, sodium bisulfate leaves behind something else called salt. As you can imagine, Joe, that also contributes to your TDS. We're going to get to those TDS numbers, which is pretty alarming. We're going to get to those in a moment, but sodium bisulfate is dry acid. It's a lot safer to handle and to store than any, hydrochloric or sulfuric acid, because it can't really spill but it's dry and you can sweep it up. But as soon as it's mixed with water, it has to be pre-dissolved. It is a very comparable acid to the others, but it is safer to handle. It doesn't fume nearly as much once it's diluted because you're already putting it directly into solution. But this is called dry acid. It is very commonly sold in pool retail stores. Okay, so if you have something like pH down or alkalinity down, it's usually going to be sodium bisulfate if it's a dry chemical. Now, Joe, in your experience with the retail stores that you've worked with extensively, and I have not, what's the percentage? Do you see more dry acid out there or liquid acid?
Especially for consumers, you see a lot more dry acid just because of the handling, and it's safer for them. But certainly you probably in most cases see at least one other option or maybe two options, maybe less than that now given the shortage situation that we're in. But there are usually options at each of the retail stores, but I think the preferred method for consumers especially is going to be the dry acid.
Dry acid, yeah. Now it's starting to work its way into commercial pools as well. So the biggest cal hypo manufacturers in the commercial pool game are Pulsar and Accutab. They have both in the last 2 years released their own sodium bisulfate feeders. I think it's Acid Plus and Acid Right. So it is gaining popularity, but again, we have to talk about sulfates. Okay, it's a good acid. It's a great product. It's easier to handle and all that stuff, but it leaves behind some TDS. So you're going to get some salt and you're going to get sulfates. Now, what's crazy about this is the amount of sulfates you get. So let's start with the amount, Joe, and then we're going to talk about what they actually are and why you don't want a lot of them. So let's start with sulfuric acid.
Yep.
For 1 gallon of sulfuric acid, how much sulfates are we talking?
47.1 parts per million of sulfates. Pretty high dose of sulfates in every gallon of sulfuric acid
In
per
how much
10,000 gallons.
Per 10,000 gallons. So 1 gallon of sulfuric acid in 10,000 gallons of water leaves behind how much?
47.1 parts per million.
That's crazy. Now I'm going to put some context to this. According to the water, I guess it's PWTAG something. It's from the UK. It's their water regulatory authority, I guess. They're an advisory group, right? They put an effective limit of sulfates at 300 parts per million. And you are putting in 47.1 per gallon in 10,000 gallons of water. That adds up extremely fast, especially if you're not containing your pH and you're chasing your pH and you're using sulfuric as your primary acid. You are going to exceed 300 parts per million quick, like in a matter of weeks. And we'll get into why that's a problem soon. But let's talk now about the amount of sulfates left behind by sodium bisulfate, which, by the way, is sold in 93.2% concentration. Not that that really matters, but for every pound of sodium bisulfate, Joe, what are we looking at?
Every pound is going to leave behind 9.6 parts per million in a 10,000 gallon pool.
So
Plus salt on top of that.
Plus salt on top of that. So you're leaving behind a pretty considerable amount with either one of those.
So let's see, by pound, let's see. So 1 pound of bisulfate, if my notes are right here, to do the equivalent of that, for every 32 ounces of muriatic acid. So let's say you have a 20,000 gallon pool, and we've done this equation a lot. So 20,000 gallon pool at 90 alkalinity, and you want to drop your pH from 8.0 to 7.5. That's about a quart. That's going to be, let's call it 32 ounces of muriatic acid. Okay. The equivalent in order to make that same correction with sodium bisulfate is 41.92 ounces. Call it 42 ounces. 42 ounces, that's more than 2 pounds. So right there, you're not just talking about 9.6, you're actually talking closer to 20 parts per million. So it is significant and it adds up over time. So let's talk about these sulfates, and then we're gonna get to carbon dioxide, which is a much easier conversation. But let's talk about sulfates. Sulfates they come in very different forms, okay, as a byproduct. So you can have SO4, you can have SO3 with a double negative valence. But the point is, Even if you have a perfectly balanced LSI and just Google sulfate concrete attack, you'll find plenty of information on this. Even if you have perfectly LSI balanced water, if your sulfates are high, you could still have etching, and a lot of it. Because what happens, I was actually just on the phone with Richard Falk today. Richard, if you're listening, thank you for your help. Blew my mind. The sulfate ion is very similarly structured to the carbonate ion. Carbonate, of course, being CO3 minus minus. And that carbon is what binds to calcium to create calcium carbonate. That is the measure that we're using in the LSI, how much calcium carbonate is in our water. Well, what happens when you have enough sulfate that it becomes the dominant ion, Joe? You have a similar ion that boots carbonate off of calcium, which means you have now broken down calcium carbonate, etching, and it replaces it. It doesn't always replace it, though. It could just boot the carbonate off and then leave and do something else, I guess. I'm not a chemist. By the way, if you are a chemist listening to this, I'm doing my best. But Richard, it is in his own words, it can absolutely replace a carbonate that is already bound to a calcium. And then you get something called calcium sulfate. And if you have enough of that and that starts to precipitate, oh no. Calcium sulfate is brutal. It is very hard to get rid of. There's a great case study. We're about to publish an article about this. In order to get rid of it, you pretty much have to grind it off or resurface your pool. There is no chemical way to get rid of it except for boiling muriatic acid. Don't do that at home. So basically, there's no effective way. You have to physically grind this stuff off. And so you really don't want your sulfates to get high enough that that can happen. And basically, from my understanding of it, it's a measure of how much calcium you have relative to your sulfates or how much alkalinity you have relative to your sulfates or something like that. I wish I had more accurate information on that. Just know that if your sulfates are higher than 300, the likelihood of this happening goes way, way up. Yeah. That is what you need to be aware of.
And that calcium sulfate, it's like a crystal scale, right, Eric? I mean, it's hard. You don't want to step on it. You don't want to touch it.
It'll cut you right up. It'll cut right through your skin.
Right.
Yeah, there's pictures of it on our site. I mean, it is a hard, translucent, sharp, razor sharp crystal, and it's from high sulfates. Now, it is a scale, unlike calcite crystals, which we deal with in our winter water chemistry that we talk about so much. They kind of grow out of the surface. This will land on anything. This will land on light. It will land on tile. It'll land on anything that it can adhere to. It does come from the water, and it just forms these really sharp crystals. So you do not want your sulfates to be too high. But, Joe, there's a lot of other products that introduce sulfate, like copper sulfate algicide,
right,
or potassium monopersulfate, right? There's a few others I could go into, but just be monitoring that you're not doing this too much. And take one guess as to the only effective way to reduce sulfates in water, Joe.
There's only one way. It's got to be drain and refill.
Mm-hmm. Well, I guess there's technically, yeah, you're correct. There's technically two if you want to do reverse osmosis. But practically speaking, most people don't have that capability. It's drain and dilute. Just like cyanuric acid, just like reducing calcium hardness, drain and dilute. If you are using these acids, I probably should have started with this sentence, Joe. If you are going to use sulfuric or sodium bisulfate, you must monitor how much you're adding to the water over time. And we'll have this article with a chart of how much sulfate you're adding. You want to make sure that you are scheduling dilutions regularly to keep these levels down. Because even if you have perfectly balanced LSI water, again, you could be etching your surfaces. And then it gets to the corrosion aspect. There's a lot of chlorides in water. We mentioned this a little earlier. All chlorines leave behind chlorides. When there's enough chlorides and sulfates in the water, you get galvanic corrosion at rates that you've probably never seen before. Now, I encourage all of you to do the research yourself. If you want to know more, do not take us as the authority on this. We did not write these sources. We do hyperlink to them in the article. So you can find it there or just Google it. I mean, just get online and you'll find the information that I'm just relaying it to you. So if I'm somewhat wrong in my phrasing, which I'm almost certainly somewhat wrong in my phrasing, but I think I've got the main points nailed down, we have to keep in mind our sulfates need to be diluted and kept down.
I think One more, potential issue, and you don't hear about it a lot in swimming pools, but every once in a while you run into it, is that smell. So if you smell that kind of rotten egg smell that you only smell when you have sulfates and metals interacting, typically from sulfates and metals interacting, a lot of people in their houses have that smell because it's going through the hot water heater and reacting there. But in a swimming pool, you can get it too if you have a high enough sulfate level and you have a heater on the pool, and it's the same kind of situation. So know if you're getting that kind of rotten egg smell, that's another byproduct of a very high sulfate level.
Yeah, I hate that rotten egg smell. And that's you were telling me the other week that's iron sulfate that makes that smell.
Yeah, or a bacteria of iron sulfate, or there are some other common reactions as well. But yep.
Right. Now, we understand that if you can't get muriatic acid, you may have to use one of these products. And we're not trying to knock the products. We're trying to make you aware of the consequences so that you can prepare for it. Because you could use sulfuric acid as your regular acid. As long as you are aware of it, you schedule regular dilutions, you'll be okay, as long as you're handling it right. That's why we're telling you all this. It's not to dissuade you from using one or the other. But one of the most common ways, especially in commercial pools and high-end residential pools, to manage your pH is actually injecting carbon dioxide. Now, we talked about this in the last, 2 episodes ago. We've talked about it in several articles, but the amount of CO2 dissolved in your water helps determine the pH of your water. All right, so the more CO2 dissolved in your water, the lower your pH. And this, Joe, is because when I add more CO2, it's going to convert into carbonic acid, H2CO3. That means it's dissolved in water, it's binded to H2O, and now I've got carbonic acid, which pulls my pH down. As the pH rises naturally, because CO2 has to off gas, Henry's law, we've done several episodes on this, as the CO2 off gases, the pH comes back up. And now you have bicarbonate and then carbonate alkalinity if the pH gets high enough. But you can basically reduce your pH simply by injecting CO2, but it will not reduce your alkalinity. And the reason for that, as mentioned in previous episodes, is the way that you get more CO2 by using acid, because think about it. What's muriatic acid, Joe? HCl. Is there a CO2 in muriatic?
Nope.
Is there a CO2 in sulfuric? No. No, there's not. You had to think about it. Hey, you know what? We're on a show. It was not a trick question.
I thought you were leading me there. I was like, wait, he's leading me. There's got to be.
Oh, okay.
No.
Oh, that's funny. No, there is no CO2. No, you know what? We're doing this in one take. So the people listening at home are going to be like, wow, I really thought that Joe guy knew his stuff until this moment in time. No, there is no CO2 in any of these acids. Okay. So where does the CO2 come from? If you have to create more carbonic acid to pull the pH down, what happens is acid throws hydrogen onto bicarbonate or carbonate alkalinity and converts it to carbonic acid. In other words, acid burns through your alkalinity to pull the pH down. This is why your acid dose is higher if you have more alkalinity. To make the same pH correction, it takes more alkalinity being converted to go down, okay? Because it's all relative. If you have 50 alkalinity, and let's say you want to make a pH correction that takes 10 ounces. Well, if you had 100, it would be 20 ounces to make the identical pH correction because you have twice the amount of alkalinity. That's if you look at the Orenda dosing app, it'll show you it's exactly proportional to your alkalinity. The more alkalinity, the more acid required. But with CO2, you can reduce the pH and ignore the alkalinity. In fact, the alkalinity is going to go up over time, mainly because the excess lye left behind with your hypochlorite chlorines. So whether it's a salt chlorine generator that creates sodium hydroxide along with gas chlorine, or liquid sodium hypochlorite or cal hypochlorite or calcium hypochlorite, those things are going to raise the alkalinity over time. So a lot of commercial operators, they kind of do both. We have CO2 feeders because it's way cheaper. I mean, way cheaper than using acid, but it doesn't tank the alkalinity. And then when the alkalinity gets too high, then they use some acid to bring that back down. And they're able to regulate things pretty well. So you have to inject it, and 1 pound of CO2, and it's kind of hard to think about CO2 in weight because it's a gas, but in a compressed tank, 1 pound of CO2 is equivalent to 32.8 fluid ounces of standard muriatic acid. 31.45%. So let's just call it a quart, okay? 1 pound of CO2 is going to make roughly the same pH correction from 8.0 down to 7.5 at 90 alkalinity on a 20,000 gallon pool that 1 quart of acid would do. So it is significantly cheaper to use, but it is more complex to install. And there's one caveat to CO2 feeders that you need to be aware of. Algae feeds on CO2. So if you have an outdoor pool, and our test pool, well, I shouldn't say it's our test pool, it's our boss's pool. We just test everything in it. He put a CO2 feeder on it and was experimenting with it. And it was awesome, saves a lot of money on pH correction. But he found out, well, number one, my alkalinity climbs, but number two, I'm getting an algae problem. So he got back on the enzyme and phosphate routine, and he got his chlorine up, and he had to shock with chlorine. He took care of it. But he was aware that more CO2 in your water is more food. Now, that all being said, you do need to supplement this, of course. You still need to chlorinate your pool and all that. We're just talking about pH control right now. CO2 will not reduce alkalinity. It will only reduce your pH. So those are your 3 alternatives. CO2 injection, sodium bisulfate, dry acid, which needs to be pre-mixed before it's added, and sulfuric acid. Joe, is there anything else you want to add for the crowd?
Just in case you've got various versions of acid laying around, never, ever put them together. Don't mix them. I mean, you can cause some really violent reactions there. There's even one where you mix muriatic acid and sulfuric acid, and it causes the aqua regia, basically dissolves gold. So you don't want that anywhere near you. But yeah, just make sure that you're sticking to one form of acid.
Yeah, another nickname for sulfuric, a little fun nickname for sulfuric acid is oil of vitriol, which is something that I guess they named back in the day, who knows when, but it's because it melted metals. And that is a pretty astounding thing to think about. So anyways, these are your acid alternatives. We're sorry that there is a shortage. We're not in the acid business, but if you have to use an alternative, just be aware of what each one is. And I hope this helps. But I also hope that you know that we're just like you. We have to learn these things ourselves. We're doing the research. We don't know all this information off the back of our hands. I've spent the last 5 days learning about this. It's new to me. I've never really thought about sulfuric acid or sodium bisulfate, and shame on me, but we're just trying to relay the information and do the best we can. Thank you so much for listening to this show. We don't know what our next topic is going to be, but it's probably going to be another current event because there's going to be another crisis coming up soon, with these supply chain shortages. So, I guess we'll just talk about that. Joe, thank you so much for being with me.
My pleasure. Thanks, guys.
Right.
Episode 31, Rule Your Pool. I'm Eric Knight with Orenda. Thanks so much for your time. Take care.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.